Given question, the values of load lifted and efforts required by a lifting machine are given in table. Determine the law of machine. If the velocity ratio is 25, calculate efficiency at each load and plot efficiency versus load curve. For this curve, determine the maximum efficiency.
Different values of effort and load is mentioned in the table, and this is the given table. For load FL, values are given in Newton, and for effort FE, values are mentioned in Newton. Now we will calculate the efficiency. So what is the formula for efficiency? So efficiency is mechanical advantage divided by velocity ratio, and velocity ratio mentioned in question is equal to 25. Where mechanical advantage is the ratio of FL by FE. So for each term or for this each column, we will calculate efficiency is equal to FL divided by 25 FE, because VR is equal to 25. Now when we calculate this, then we will get the different values for efficiency. First question, we have to find out the law of machine. Where law of machine is FE is equal to M into FL plus C. We have to find out value of M and value of C. So we will plot the graph. We will plot the graph for effort, that is FE value on vertical line, and FL, that is the load value on horizontal line. Now we will take some specific distance. So I will take some distance, that is the scale, with 2 cm or we can say 5 cm as per this space available, and we will start from 0. So if we observe the values of load, it will vary from 100, 200 up to 500. So this 5 cm distance is equal to 100 Newton. So 0 to 100, 200 up to 500. And on vertical line, values of effort is 16, 22 up to 40.49, that means up to 50. So we will take scale, that is 5 cm is equal to 10 Newton. So it will start from 0, 10, 20 up to 50. Now we will plot the graph. Now if we observe for the load of 100 Newton, effort is 16. So here is the 100 Newton, and in between 10 and 20 we have to find out the middle point. So with the help of scale we will find out middle point, and then slightly above that we will select the value of 16. Then next is for 200, it is 22.49. So here is 200 load and then 22.49. So I will select here. So in between 20 and 30 we will first select the middle point, and then in between that we will select the value of 22.49. Then for 400 it is 34. So here is 400 and then we have to take the 34. So in between 30 and 40 we will select the middle line, and slightly below that we will select the value of 34. Then for 500 it is 40.49. So for 500 we will select slightly above 40, 40.49. So these are the points. Now we have to join these points with the help of straight line, and then we will find out its a slope. So when I attach all these points with straight line, then this is the slope for actual machine. So if we observe at the 0, here is the intercept, and this intercept, so suppose I will say this point is O, and then suppose this point is A, then OA is nothing but intercept, so value of C is equal to 10. Now we will find out the value of M. So I will connect the points. So I will connect the vertical line and horizontal line. So I will select this point 22.49, on vertical line, and on horizontal line I will select this 10 Newton. Now if I select this angle as a theta in this triangle, then we can say that M is equal to tan of theta, and which is equal to opposite side. So what is the length of this vertical line? Now from this 0 up to this total height is 22.49 minus 10. That means opposite side is equal to 12.49 divided by nearby side. So this horizontal line length is from 0 to 200. That means 200. So when we solve this, then we will get the answer 0.06. So value of M is equal to 0.06. So how we can write the law of machine? So Fe is equal to M, that is 0.06 Fl plus C. Value of C is 10. So this is the law of machine for the given data. Now we will plot the graph for efficiency versus load. Now we have calculated this efficiency in percentage. That means we have used formula FL by FE into 1 by VR, that is 1 by 25. And then we have converted into percentage by multiplying with 100. Now we will plot the data. Now for the load of 100 Newton, efficiency is 25. So for 100 Newton, we will select the middle point in between 20 and 30. So here is the point. Then we will move next for 200 Newton load, it is 36.5. So for 200, we will select the middle point, and then slightly above that there is 36. Then for 400, it is 47. So for 400, we will select the middle point in between 40 and 50, and slightly above that we will use the 47. And then for 500 Newton, its efficiency is 49.3. So slightly below 50 we will use the line. Now we will connect all these points. So we will connect all these points with the help of smooth curve. So this is the graph for efficiency in percentage versus full load in Newton. So the load in Newton. Now we will calculate maximum efficiency. So we have formula to calculate maximum efficiency, that is maximum mechanical advantage divided by VR. So maximum mechanical advantage, that is 1 by M, and divided by VR, that is 1 by VR. So M value is 0.06 and VR is given 25. So when we calculate, we will get 0.6667. So we have to find out this efficiency in percentage. By multiplying with 100, we will get the answer 66.67%.